approach to, this is one thing which I wanted to give you a perspective. A lot of times what happens is just one pass of one algorithm is not good enough for a machine learning scenario. That's when we have this concept of ensemble classifier. So what people do is, let's assume you have a doctor, you have a symptom, and you want to go and get diagnosis of some issue you have been facing. Suppose you're diagnosed with somebody says cancer. It's a fair idea that you will go and consult multiple doctors. You may go and consult a second doctor. It's called second consulting. Or you may give better weightage to somebody who is a specialist. So that is where we have this concept of ensemble algorithms, where we try to run multiple machine learning algorithms or same algorithm across multiple times in different parts of the sample, and then either take a majority voting, which is bagging, or we try to give a boost to specialist components, which is what is known as boosting. So these are also known as meta algorithms. Meta algorithms are very important in machine learning because a lot of times just a single pass, single machine algorithm is not good enough. So bagging, as I said, is a basic idea where you try to look at how you can take a separate the initial data into separate chunks, and for each of them run the same algorithm but produce an average of the result across. Sorry, bagging is that. So each part of the input can be tried with different machine learning algorithm. It could be same also. Then you can take the average of that. That is becomes your model. In some cases, boosting would be basically, you can say that if I can continually apply that on repeated sampling of the same set, so that you increase the precision and decrease the variance. Variance means it won't differ for different samples. Yesterday we saw, right, bias variance. Bias means depends on the same sample. Variance means we get different models for different data sets. For the same data set, for different samples, you're getting different input functions, which is what you have to avoid. The last one is stacking, which you already have been doing. In the sense, we have been doing k-fold validation technique, right? Tenfold validation, which is what we say that you take 1/10 of the sample, try same algorithm, then try for different 1/10, different 1/10. So if you look at all of this, they're not inventing a new algorithm, but they're using an existing algorithm. It could be a decision tree, it could be linear classifier, but then they try to say apply it multiple times, take average, or take a specific data set, take the output, again apply it on that. So that is boosting, right? So you can do either boosting, bagging, or stacking to improve the effectiveness of your machine learning.